In this class, I will show you the Lewis structure of sulfur trioxide. Now the formula of sulfur trioxide is SO3. So first we have to calculate the total number of valence electrons. We know the outer shell electrons of sulfur is 6. The number of outer shell electrons of oxygen are 6, and there are 3 oxygen atoms in this compound, so 6 into 3, and total number of valence electrons are 24. Now the central atom of sulfur trioxide is sulfur, as it is the least electronegative element between sulfur and oxygen, so it will act as a central atom. Now we have to arrange other elements like oxygen here in this situation. Okay, then I will make, or you will make, a single bond between oxygen and sulfur. There are 3 bonds here, this one, and this one. In each bond there are 2 electrons, so 6 electrons are used in here. So out of 24 electrons, there are 18 electrons are remaining, and we will place them on outer oxygen atom like this one: 2, 4, 6, 2, 4, 6, and 2, 4, 6. All electrons are used in this structure, so it may be the structure of sulfur trioxide. Let's check out. So we have to calculate the formal charge of sulfur trioxide. For 3 oxygen atoms, 1, 2, 3, as they are the same oxygen atom which are bonded with sulfur with single bond. So for 3 oxygen atoms, formal charge of oxygen is equal to valence electron 6. As you know, the valence electrons of oxygen are 6, minus lone pair or non-bonding electrons in each oxygen atom, as there are 1, 2, 3, 4, 5, and 6 non-bonding or lone pair of electrons are in here, so this is 6, minus bonding electron divided by 2. For this oxygen, there are 2 electrons. It is singly bonded with sulfur, and in each bond there are 2 electrons, so bonding electrons are 2, and this 2 comes from formula. So 6 minus 6 minus 2 by 2 equal to minus 1. Each oxygen atom in this compound has formal charge minus 1. For one sulfur atom or central sulfur atom, formal charge is equal to 6, as there are 6 valence electrons, so this is 6, minus there are no lone pair or non-bonding electrons are in here, so this is 0, minus as there is 3 single bond in here, so there in each bond we know 2 electrons, so there are 6 electrons in this compound or bonding, so 6 divided by 2, so 6 minus 0 minus 6 by 2 equal to plus 3. So the central sulfur atom has formal charge plus 3. So is it the structure of sulfur trioxide? The answer is no, it's unhappy. So why this is not the structure of sulfur trioxide? Okay, the first one, the central atom do not follow octet. It has 2, 4, and 6 electrons, as there it's not follow the octet rule, so it will not be the structure of sulfur trioxide. And the second one is we can make another approach for formal charge calculation, where the formal charge of each element like oxygen and sulfur may be 0 or closer to 0. Let's try another one. We draw in this structure two lone pair of electrons or non-bonding electrons are withdrawn from here between oxygen and sulfur, and it makes a bond between oxygen and sulfur, and this and these are the same. So now the structure is like here. So if you ask you, it is the structure of sulfur trioxide, the answer is yes. Now it is happy. So why is the structure of sulfur trioxide? Okay, it follows octet expansion rule, or octet expansion is satisfied here. So why octet expansion is occurred here? As sulfur is has 3d orbital, and we know for d orbital octet expansion may occur, so it will follow octet expansion. And the second one is formal charge of sulfur is equal to 0. If we calculate the formal charge of sulfur in this compound or structure, it will be 0. And for 3 other oxygens, it will also be 0. As it satisfies the formal charge rule, so this will be the structure of sulfur trioxide. Thank you for watching this video.